All right, welcome. Today, we're not just talking theory. We're going to run a practical, hands-on drill to architect a real-world disaster recovery plan for critical storage right on AWS. Let's get into it.
So let me just start with a question. I'm sure your backups are running, right? The little green light is on. But in a real, full-blown disaster, is your business actually recoverable? You see, having backups is one thing. Having a proven, tested plan to get back up and running, that's a whole different ballgame. Today, we're going to close that gap. Okay, let's set the stage. For this explainer, I want you to put on your architect hat. You're in charge, and your mission, should you choose to accept it, is to guarantee the survival of a specific portfolio of absolutely business-critical assets. So what exactly are you protecting? Well, here they are. First up, a high-transaction OLTP database. This is the absolute heart of your application, you know? It's handling all those real-time customer orders and updates. Next, a file share, maybe not as high-strung, but essential for daily operations. And finally, you've got this massive, high-importance S3 data lake. That's the brain, fueling all your analytics. Yeah, the stakes are pretty high for all three. Now, before we build a single thing, we have to define what success even looks like. We measure that with two key metrics, RPO and RTO. Think of RPO, a recovery point objective, as your data loss tolerance. How much data, measured in time, can you really afford to lose? An hour? A few minutes? And then there's RTO, recovery time objective. That's all about downtime. How fast you have to be back online. Our entire strategy is going to hinge on hitting these numbers. With our goals locked in, it is time to architect our defenses. You know, a successful recovery doesn't start when disaster strikes. It starts way before that, with a smart, automated, and robust backup architecture. Let's see how this builds out for each asset. For our critical database, it's all about speed and minimal data loss. The plan is simple, but really powerful. We use AWS Backup to automate snapshots. Then we automatically copy those snapshots over to our disaster recovery region. And of course, a clear retention policy ensures we're not keeping more than we need. This whole setup directly targets a very, very low RPO. Now for the file share, the process looks pretty similar on the surface, right? Schedule regular snapshots, copy them to the DR region. But here is the crucial bit people often miss. We have to test the restore of permissions and metadata. I mean, a restored file that nobody can access is completely useless, so this validation step is absolutely non-negotiable. Okay, and what about that massive S3 data lake? Trying to snapshot that would be, well, a nightmare. So instead, we're going to use S3's native superpowers. First, we enable versioning. That's our safety net against accidental deletions or overwrites. Then, we configure cross-region replication, or CR. This automatically creates a near real-time replica of our entire data lake in the DR region. It's just elegant and incredibly effective. So our backups are humming along for all our assets. We're safe, right? Well, not yet. A backup architecture is just a theory until it's been tested under pressure, so it's time for a fire drill. And this quote just says it all, doesn't it? Hope is not a disaster recovery strategy. The only way you turn that hope into a guarantee is through regular, documented, and rigorous testing. All right, let's simulate the worst-case scenario. We've just received the alerts. Our entire primary AWS region is offline. This isn't a single server failure, it is a major event. The DR plan is now active and the clock is ticking. Just watch how our plan unfolds. At time 0, we get the alert. Within 5 minutes, the DR protocol is officially initiated. Now, the really amazing thing here is the speed. Just 15 minutes in, the database is restored from its latest snapshot in the DR region and is fully operational. By the 45-minute mark, the file systems are restored. And then, at the 1-hour mark, all systems are go, and traffic is fully routed to the DR region. Let's just pause on that first victory for a second. 15 minutes. For our most critical asset, that transactional database, we went from total region failure to fully operational in another part of the world in under 15 minutes. That is the power of a well-architected and, more importantly, a well-tested plan.
And the overall result? Full business continuity for the entire portfolio was achieved in just 60 minutes. We met our RTOs with plenty of time to spare, proving our architecture wasn't just some theory on a whiteboard. It was a resilient, effective defense.
Seeing it work in a simulation is one thing, but now, let's make sure you can apply this yourself. Here is a practical playbook, a checklist you can literally adapt for your own team's fire drills.
This right here is your takeaway, a checklist to run every single quarter. Start by defining your scope. Then, after scheduling a window, you run the actual restore. But don't stop there. The most critical steps are next. You have to validate the data integrity and the application connectivity. Can the app actually use the restore data? Finally, measure your performance against your goals, and most importantly, document everything you learned to improve for next time.
So we'll leave you with this question to think about for your own environment. After seeing this drill, what is the single most important, or maybe the most overlooked, component in your system that you need to schedule a recovery test for? Your answer to that might just be the thing that saves your business.